Hi everyone. By the end of this video, you will have a clear idea on dimensions, principle of homogeneity of dimensions, and how to use principle of homogeneity of dimensions in deriving equations showing the relationship between different physical quantities, converting from one system unit to another, check the correctness of non-equations, and some MCQs, some ARQs, and some numericals. What do you mean by dimension of a fundamental quantity? For that, let's see the first fundamental quantity, which is length. The first letter of length, L, is the dimension of length. Same way, mass, M, time, T, but for temperature, we cannot choose T because it's already taken. So we go for the unit K as the dimension of temperature. Same way, the dimension of electric current, we just go for the unit, which is ampere. These are the main 5 fundamental quantities and the dimensions you have to deal with grade 11 and 12. There are 2 more fundamental quantities, luminous intensity, amount of substance. So we don't need to know about the dimensions of those 2. What do you mean by dimensional formula? It is just showing the dimensions of fundamental quantities as the powers. Look at this. We know the dimensional formula of force is m to the power of 1, L to the power of 1, T to the power of minus 2. That shows product of m to the power of 1, L to the power of 1, and T to the power of minus 2. So basically, dimensional formula is the product of powers of fundamental dimensions like m, L, T, A. In general, the dimensional formula of a physical quantity is written m to the power of x. X is just a number like 1. Y and Z are numbers, which is showing the power of fundamental quantities. Now, how do we find the dimension of speed? The first thing, you have to know the equation of speed, which is distance over time. Distance is a fundamental quantity, length, so just L, and for time, just T to the power of 1. To show that there is no other dimensions like mass, length, etc., we just put 0. Physics over mathematics, which shows m to the power of 0, L to the power of 1, and T to the power of 1. When it goes to the top numerator, it becomes T to the power of minus 1. So this is the dimension of speed, which tells you it doesn't contain the fundamental quantity mass. It contains fundamental quantity length as to the power of 1, time to the power of minus 1. Let's find the dimensional formula of acceleration. For that, we need to find the equation for acceleration, which is velocity divided by time. The dimension of velocity, same as dimension of speed, L, T to the power of minus 1, divided by T. The divided by T, when it goes to the top, it becomes T to the power of minus 1. Already there is T to the power of minus 1. With this T to the power of minus 1 going up, it becomes T to the power of minus 2. So L, T to the power of minus 2 is the dimensional formula of acceleration. We move on to getting dimension of force. The formula for force is mass times acceleration. Dimension of mass, just m. And dimension of acceleration, just now we have done L, T to the power of minus 2. Combining them together, m to the power of 1, L to the power of 1, and T to the power of minus 2. We move on to getting dimensions of temperature gradient. Always remember, gradient means divided by distance. So temperature gradient means temperature divided by distance. Dimension of temperature, which is just K, and dimension of distance is L. No other dimensions are involved, so all of them 0. Which gives you L to the power of minus 1 and K to the power of plus 1. Keeping m to the power of 0, T to the power of 0, just to show that it doesn't contain dimensions of mass and time. What do you mean by dimensional equation? It is an equation showing the dimensional formula with the physical quantity, showing an equation. So this is dimensional equation. Dimensional formula of speed equals m to the power of 0, L to the power of 1, T to the power of minus 1. Another example, dimensional equation of acceleration. Dimensional formula of acceleration is this. Showing the dimensional equation of force, we did before. Same, we classify all the physical quantities based on their dimensions. Some of them may have no dimension, but they have a fixed value. We call them dimensional variables, which means they have a dimension and they have no fixed value. Examples are all the measurable quantities like force, velocity, acceleration, etc., etc. They have dimensions, but the value is not fixed. The second set is dimensionless variable, which means no dimension, but it has no fixed value at all. So these are the quantities with no dimension, but without fixed value. Refractive index we learned before, which is the ratio of speeds, so no dimension, and it has no fixed value. Water has a refractive index 1.3, glass has a refractive index 1.5. Plane angle, solid angle, etc., etc. Dimensional constant. They have dimension and it is a constant, which is a fixed value. All the constants in physics. Gravitational constant, the letter we use is capital G. Gas constant, capital R. Planck's constant, H, etc., etc. are dimensional constants. We go for dimensionless constant, which have no dimension, but they have a fixed value. Pi 3.14 has no unit, no dimension, but it has a fixed value. And the constant numbers like 1, 2, 3, 4, etc. Now it's a question, MCQ. A unitless quantity is it always a number? Yes. It can be a physical constant without dimension, possible. 3.14. Have no dimension, that is also possible. So all the three. Which of the following is not a dimensionless quantity? I repeat, dimensionless quantity means ratio of similar quantities. Angle, arc divided by radius. Arc is length. Radius is also length. So it has no dimension. Specific gravity. Ratio between density of a liquid divided by density of water. Again ratio. Strain, change in length divided by original length. So they have no dimensions. Density is mass divided by volume, which has a dimension of ml to the power of -3. So the answer is D. Another MCQ. If the dimensional formula of physical quantity is m to the power of 1, l to the power of 2, and t to the power of -2, then the physical quantity is, we have to find them, is it torque, impulse, force, or force per area? Torque, I can tell you, it is force times distance. The dimensional formula, force is ml t to the power of -2 times distance is again l. That will give you ml squared t to the power of -2. So the answer is torque. I can show you impulse is change in momentum, which is mass times change in velocity. Mass m, change in velocity lt to the power of -1. So that's not force, you remember? No. Force per unit area, which is force m l t -2 divided by area is l square. When l square goes to the top, it becomes l to the power of -2. This one and this -2 becomes l -1 t to the power of -2, which is not. So the correct answer is A. Next, we move on to physical quantities having same dimensional formula. You need to remember them. Distance, displacement, radius, light year, wavelength, radius of gyration, all of them are distances. So they have same dimension L. Speed, velocity, velocity of light, etc. lt to the power of -2. Acceleration due to gravity, intensity of gravitational field, centripetal acceleration, all of them are acceleration. So lt to the power of -2. Then impulse, change in momentum, they have the same dimension, mlt to the power of -1. Force, weight, tension, thrust, energy gradient, which is energy divided by time, all of them have same dimensions. Then we move on to work, energy, moment of a force, torque, moment of a couple, all of them have the same dimension, ml squared t to the power of -2. Force constant, surface tension, spring constant, energy per unit area, all have m t to the power of -2 as the dimension. Angular momentum, angular impulse, Planck's constant, all of them have same dimension, ml to the power of minus 2, t to the power of minus 1, angular velocity, frequency, velocity gradient, decay constant, rate of disintegration, all of them have a simple dimension t to the power of minus 1. Stress, pressure, modulus of elasticity, Young's modulus, etc. They have the same dimension, ml to the power of minus 1, t to the power of minus 2. Electric field and electric potential gradient have the same dimension. Surface tension, surface energy, force gradient, spring constant, all have the same dimension, mt to the power of minus 2. Light year, wavelength, radius of gyration, all of them are distances, so they have the dimension of L. That's it. We do some questions. Which of the physical quantity is similar to dielectric constant according to the dimensional analysis? Dielectric constant, you will learn later, is the ratio of two forces. Since it is ratio, no dimension, you remember strain is change in length divided by original length. So strain has no dimension. So the answer is B. The next MCQ is the product of energy and moment of inertia has the same dimension as which among the following? For that, we have to know the dimensional formula of energy. Then we have to times it by the dimensional formula of moment of inertia. Energy is F times D and moment of inertia is M times R square. Dimensional formula of F is mLt to the power of minus 2. Dimensional formula of D is L, and then dimensional formula of M is M itself, R square, L square, taking the product M to the power of 2, L to the power of 4, T to the power of minus 2. So this is the dimensions of product of energy and moment of inertia. We had to find the square of the dimensions of linear momentum. Linear momentum has a dimension formula, mass times velocity, which is mL t to the power of minus 1. We have to square it, so to the power of 2, which gives you m square L square t to the power of minus 2, which is not the same as that, so wrong. We have to find square of the dimension of angular momentum. For that, we need to know the equation of angular momentum, which is mr square omega. The dimension is m, the mass, r, the radius, which is L square, omega, angular velocity, which is angle divided by time. Angle has no dimension, so divided by time, it becomes t to the power of minus 1. Squaring it, m to the power of 2, L to the power of 4, t to the power of minus 2. That matches with that, so the choice is B. But still, I'll continue. Angular impulse, the formula for angular impulse is mr square omega. M stands for mass, r, L square, omega, t to the power of minus 1. Doesn't match with that. Next is dimensional formula of Planck's constant. The formula for Planck's constant is H equals E divided by F. Energy divided by frequency. Dimensional formula for energy is mL square t to the power of minus 2 divided by frequency is t to the power of minus 1. This minus 1, this minus 2 cancels. Eventually it becomes t to the power of minus 1. So that becomes mL square t to the power of minus 1, which also doesn't match. So the final answer is B. Let's move on to principle of homogeneity. What does principle of homogeneity mean? It states that only physical quantities of the same dimensions can be added or subtracted, which means if you add y with another physical quantity z to get x, then dimensions of x and dimension of y and dimension of z should be the same. Another example, look at this. You are adding u with at to get v. This means dimension of v, dimension of u and dimension of a and t together should be the same. Another example, look at this. Y equals a sine omega t minus kx, omega t minus kx, which means kx and omega t should have the same dimensions. And one more thing, since it is sine of this, means sine of an angle, so these two should have same dimension as the dimension of angle. We move on to what are the uses of dimensional analysis. There are three uses. Use number 1, to check the correctness of given equation. The second use, convert from one system unit into another. We will do as a numerical. And the next one, to derive an equation showing the relationship between different physical quantities. Maybe I'm writing F equals mv squared divided by r. We can derive this formula for an expression for F in terms of mass, velocity, and radius. We move on to the main limitations of dimensional analysis. Dimensional analysis has certain limitations. The main limitation is we cannot find dimensionless quantities because it is using dimensional formula. The constant of proportionality cannot be determined. Then this method fails to derive trigonometric functions, logarithmic functions, and exponential functions, all mathematical functions. Trigonometric functions, I can say, like sine of something. Logarithmic function means like sine, log of something. An exponential function means exponent of something. All this fails, which you will learn in maths in detail. What are these functions? Another limitation, this method fails to derive an equation which relates more than three physical quantities. This is applicable to derive mv square over r. How many physical quantities are there? 3. So this is applicable for a maximum of 3 physical quantities. It fails if there is more than 3 physical quantities. That's all. Thank you so much.